Hi guys, this is Mrs. Warner coming to you live from my home. Well, actually not live because I'm recording this, but that's okay. I am in my home. All right, so first of all, we are going to do simplifying radicals today. I'm so excited. I checked out your Delta Math. It seems like some of you guys are radical animals already, but for those of you who need a little refresher, this is going to be great practice for you. Okay, so here we go. We got different parts of a radical. Let's check them out first. All right, so first of all, this whole thing here is called a radical. Oh, shoot, let me get my pen turned on. Let's lose blue, that's fun. Okay, so this whole thing is called a radical. And the whole thing that kind of looks like the square root, we usually call it, is called the radical symbol. Now, sometimes there's a little number on the outside of here. There might be a 4 or a 3, and if there's no number that's outside there, it's assumed to be a 2, meaning a square root. But that little number that's outside there is called the index. And then whatever's underneath here, like maybe the number 38, that is called the radicand. So the radicand is the number that's underneath the symbol. And the little number on the outside is called the index. Okay, so the first example says for each radical, determine the index and radicand. This is going to be a piece of cake. So first off, let's find the index on these guys. Okay, so on the first one, there's no number on the outside of the symbol. So remember, that means it's a square root, or the little power is 2. But on the second example, there's a 3 out there, so that means take a cube root of that 16xy. The radicands are simply the numbers underneath there. So on the first one, the number underneath is the number 24, and on the second one, it's 16xy. Even though there's an x and a y, they can still be underneath there, and we could take the square root of those, but not today, because that would be crazy. Okay, so let's look at how to actually simplify them, now that we know the different parts. To simplify the radical, we're first going to look to this fabulous list of perfect squares that I put on the side. So if you're someone who does not have them memorized, I highly suggest knowing how to find that chart in your note sheet. So for example, like 3 squared is 9. That means 9 is a perfect square. And if you were to take the square root of it, 3 would be the answer. The square root of 9 is 3. So for the first example, square root of 28, I'm going to look on this list and I'm going to look at the numbers on the right-hand side, and I'm going to find which one divides into 28. So of those perfect squares on the right, the number 4 divides into 28. And I always want to pick the largest perfect square that is there because it'll give me the least amount of work that I have to do for the problem. If you don't pick the largest one, then you may have to simplify the radical more than once during your problem solving. So 4 times 7 is 28. So I simply write the 2 factors down and I put the square root of 4 first because that one is the perfect square. And since I know the perfect square root of 4 is 2, he now is released from that symbol of the square root sign. And the 7, who does not have a perfect square, for example, if you typed in radical 7 on your calculator, it would give you a decimal. That would be crazy. He's naughty, so he stays underneath that radical sign. And your final answer is 2 radical 7. That was so fun. We should do another one. Let's do it. Okay, so we have 6. Who put that 6 out there? I did. And then it says radical 49. Okay, so if we look on the side, jackpot, 49 is one of the numbers on the side. Whoa. So that means this is really 6 times 7. Because see how the 49 is a perfect square? 7 times 7 is 49. And if I take the square root of it, it's just 7. So now, when there's a number on the outside, I simply multiply it by that coefficient. So 6 times 7 is 42. And there is my answer. Wow, that was fun. Let's try another one. Okay, so we have 27. There's a 2 out front, but that's okay. I'm looking for 2 numbers to put under those radicals, and one of them has to be a perfect square that divides into 27. So I'm going to go to my list again, and sure enough, the number 9 goes into 27. I just start looking down my list to see. 1 goes in, obviously. 4 doesn't, so I'm not going to pick that one. But 9 does. 9 times 3. Now, that becomes 2 times 3, radical 3. And 2 times 3 is how much? 6, radical 3. Leave that radical 3 underneath there because he's naughty. He's not a perfect square. So much fun. Let's try one more. 1/2. Whoa, Warner, you put a fraction out there. That's okay. It's a half. We can do it. Okay, so now I know I need to find 2 factors, and I'm going to look for the biggest one. So if I'm looking down my list, whoa, that's crazy. If I'm looking down the list for the biggest perfect square that goes in here, I'm going to kind of start like up in here somewhere. Like I know 100 won't divide in. I know 81 won't, but 64 will. 64 is big, and it goes in there 2 times. So if I do 64 times 2, that gives me 128. Now I haven't worked with that half yet, but I'm going to take half. The square root of 64 is 8. So I'm going to take half, times it by 8, and radical 2, who is not perfect, stays underneath. Half of 8 is 4, radical 2. That's so much fun. I love it. So your task is to complete the 4 practice questions, number 5, 6, 7, and 8, and submit your answers to see if you're getting them right or not. You can do it. You're going to be a rock star at this. And that's all for today, folks, for lesson 1.1. Stay tuned for lesson 1.2.